everyone, welcome back to my YouTube channel. In this video we are going to show that the radius of curvature at any point of catenary y is equals to c cos hyperbolic of x by c is equal to the length of the portion of the normal intercepted between the curve and the axis of x. Okay, so here we first have to find the radius of curvature for this, and then we have to find the length of the portion of a normal and see length of the portion of the normal. Okay, and then see that they both are equal or not, and anyhow this is show that so it is equal only. We just have to justify it, or we just have to show it. Okay, so the curve is given as y is equals to c cos hyperbolic x by c. So this is cos hyperbolic is one function. X is not the part of angle here. It is hyperbolic. It's a trigonometric hyperbolic function. Okay. So this we have to differentiate this with respect to theta. Trigonometric identities and trigonometric hyperbolic identities are different from one another. Okay. So differentiate with respect to x, not theta. Sorry. So differentiate with respect to x. Here y1 is equals to, this will become c into cos h. In hyperbolic, differentiation of cos hyperbolic is sine hyperbolic. It's not negative sign, it's positive sign hyperbolic, and this is x by c is the angle, correct? And differentiation of x by c is 1 by c. So this c and c will get cancelled. So y1 is nothing but sine hyperbolic of x by c. Done. Now we will differentiate this again with respect to x. So the answer will be sine hyperbolic x by c, right? So for this, differentiation is cos hyperbolic x by c, and the differentiation of x by c is 1 by c. So the answer I can write as 1 by c cos hyperbolic x by c. Okay. So I have y1 and y2. So the radius of curvature formula, we know that rho is equals to 1 plus y1 square whole to the power 3 by 2 divided by y2. Correct? Now we will substitute y1 and y2 in this formula and get the radius of curvature. So radius of curvature is equals to 1 plus y1 is what? Sine hyperbolic. Here we have square, so hyperbolic square x by c whole to the power 3 by 2 divided by y2 is what? 1 by c cos hyperbolic x by c. Done. So we know that from the formula, okay, hyperbolic formula, from the trigonometric identities, okay, hyperbolic identities, cos hyperbolic square x minus sine hyperbolic square x is equals to 1. For just sine x plus cos x is equals to 1, just because this is hyperbolic, we have a different identity, right? So I can write this as 1 plus sine hyperbolic x is equals to cos hyperbolic x, right? So I will substitute this formula using this formula in this equation. So rho is equals to 1 plus sine hyperbolic, this I can write it as cos hyperbolic square x whole to the power 3 by 2 divided by 1 by c cos hyperbolic x by c, cos hyperbolic x by c. Okay, so till here it is clear. Now in the next stage we will do rho is equals to cos hyperbolic square we have plus whole to the power 3 by 2 we have, right? 3 whole to the power 3 by 2 we have. So cos hyperbolic into 3 by 2 angle x by c, correct, divided by cos hyperbolic x by c. Here we have 1 by c, so that I will take it in the numerator, so it will be c by 1. So rho is equals to 2 and 2 will get cancelled, cos hyperbolic cube into x by c divided by cos hyperbolic x by c into c. Okay, so this and this will get cancelled. Rho cos hyperbolic square x by c into c. Okay, so from the question, if we have cos hyperbolic here, cos hyperbolic square x by c, angle x by c. So from the question, this let me consider as equation 1. So from here I can find the cos hyperbolic x by c, right, value of this. So the question is what? Y is equals to c cos hyperbolic x by c, right? So cos hyperbolic, value of cos hyperbolic x by c, I can write it as y by c. Okay, y by c. So rho is equals to, now here I have c into, this is the value cos hyperbolic square x by c. This I can write it as it is square, I will write it as y square by c square whole square. I have written the square separately. So square and c will get cancelled. Radius of curvature will be y square divided by c. Okay, so this is one part of the question. Here we found the radius of curvature for this equation, that we have to show that it is equal to the length of the portion of the normal intercepted between the curve and the axis of x. Okay, so excuse me. So the formula to find the length of the normal, I will write here. Okay, length of the normal intercepted between the curve and the x-axis. This is what we have to find, x-axis, okay, or the axis of x. So the length of normal formula is nothing but y into 1 plus y1 whole to the power 1 by 2. Okay, so this can be written as y into 1 plus, what is y1? Y1 is sine hyperbolic x by c. So as I have square, this is square. Okay, so as I have square here, it will become sine hyperbolic square x by c whole to the power 1 by 2. Okay, so this can be further simplified to y into, as I have discussed this formula earlier, that 1 plus sine hyperbolic square is nothing but cos hyperbolic square. So cos hyperbolic square x by c whole to the power 1 by 2. So this I can write it as cos hyperbolic square into 1 by 2 angle x by c. So 2 and 2 will get cancelled. Y cos hyperbolic x by c. We know the value of cos hyperbolic x by c from this equation, right? Cos hyperbolic x by c. So it is y by c. So y into y by c. So it will become y square by c. Okay, so this y square by c, this and the radius of curvature are equal, right? So hence it is equal. Thank you for watching this video. If you found this video helpful, do not forget to subscribe, share it with your friends as much as possible so that they will also get benefited. And if you have any doubts, just put it in the comment section. I'll be happy to help. Thank you so much for watching.